So what we're going to do now is we're going to turn our attention to applying arbitrary-arity methods. And if you recall, there's a pair of arbitrary-arity methods in the CompletableFutures API, and that's the all of and any of method. And we're going to focus on all of. And we're going to do this in the context of collect. So if you recall, right before collect is called, we have flat map, which is going to end up outputting a stream of completable futures with a whole pile of images that are being downloaded and filtered and stored asynchronously. So there's just going to be a boatload of asynchronous stuff going on here momentarily. Nothing has started to run yet, by the way. When collect is hit, then the wheels start to turn, and that starts everything else running asynchronously. But remember, collect wants to return a single thing, right? So what is it going to return? Well, it's going to end up returning a completable future, and that's going to be returning a completable future because we're going to call this factor method called toFuture, which will make us a completable future. So collect starts the wheels in motion and then collects the results into a single completable future that completes when all the completable futures in the stream complete. And this is what is just so absolutely mind-bogglingly cool about all this stuff, is you can write all this code and make it very syntactically concise, but there's all this stuff happening under the scenes that you don't have to care about in order for things to work. Now, what we get is this completable future, which triggers only when everything else is done. And when everything else is done, it registers this action here. And what this action is going to do is it's going to take the stream of completable futures. Now, here's what's interesting about the stream of completable futures. This stream of completable futures is going to contain some results that have actual downloaded and filtered and stored images in them. Those are the ones that weren't cached. And it's also going to contain a whole boatload of things that may have already been downloaded and cached before. So that's where all those empty optionals are going to come from. Well, we want to get rid of empty optionals. So what we're going to do here is we're going to use stream.flatMap. So this is the stream that may contain empty optionals. We're going to use stream.flatMap. We're going to pass in optional : stream. And so what that's going to do is that's going to end up removing all the empty optionals. So with Java 9 and beyond, flatMap can take an optional stream, which will remove anything from the stream that's empty. So you'll only end up with non-empty optionals. So that's what that's doing. Interestingly enough, if you're stuck with Java 8, which you shouldn't be stuck with Java 8 anymore because even Android now supports Java 11, so of course it supports what's in Java 9. If you're stuck with Java 8, you have to do a little bit of extra syntactic stuff. You have to say stream.filter, optional : is present. What that's saying is only allow optionals that are present to be passed through that filter's predicate. And then you use map to get the results of optionals that are present. So I think you'll agree that that's a little bit verbose, and that's why Java 9 added this new flat map feature on stream that takes an optional stream, which gets rid of empty optionals. So you don't have to write code like this, which is more verbose. So basically, it's just more verbose. And then finally, at the end of all this stuff, everything else has been running asynchronously. We call the join method. That waits for all the asynchronous processing to complete. Once again, just to reiterate, for those of you who came in late, join is something that you should use sparingly, if at all. We have to use it here because we don't want to run off the end of main, because it's a console program. But nevertheless, join will block. We want to avoid blocking as much as possible. We have to block in this case. You usually are better off using things like completion stage methods instead of calling join, but we had to call join here. And there is only one call to join in this entire async stream pipeline, which is very good. Once everything has been downloaded, then there's another feature that allows the Android device to display the results. So you can see the images that are downloaded. Okay, that's the end of applying arbitrary-arity methods. We still have one more lesson we'll do here in a second.